Hello everyone, welcome back to my channel. So in this video we'll solve two more problems on line integral. Okay, so in my previous video I have given you the concept of line integral and the procedure to find the line integral. Okay, so here we'll solve two more problems on line integral so that we can still build a good concept on line integral. Okay, so if you're first time to my channel, please consider subscribing and encourage me to do more videos like this. Okay, so you are asked to find the line integral of z dz along C, where C is y is equal to x, y is equal to x square. I have taken the same curves as my previous example. Okay, so in the previous video I have done an example, so there also I have taken these curves only. Okay, just to tell you one point. Okay, I'll tell you at the last. Right, so y is equal to x, first curve is y is equal to x, then z is equal to x plus iy, so it will be x plus ix, so it will be 1 plus I into x, so then dz is equal to 1 plus I into dx. Okay, 1 plus I into x, so z is equal to x plus iy you have to take, so in the place of z you have to take x plus iy, but since x is also equal to y, so it is x plus ix, so 1 plus I into x, so z in the place of z you have to take 1 plus I into x, in the place of dz you have to take 1 plus I into dx. Okay, so the integral, given integral, that is integral 0 to 1 plus I z dz now becomes integral 0 to 1. Why 1? Because your integration is with respect to x and x is real part of 1 plus I. Okay, limits also changes. Right, so x is real part of 1 plus I. Real part of 1 plus I is 1, so I am taking 1 here. Okay, so what is z? Z is 1 plus I into x. Here 1 plus I, z, because z is equal to x plus iy and y is equal to x, you will get 1 plus I into x. And what is dz? It is again 1 plus I into dx. So 1 plus I into 1 plus I is 1 plus I square, which is constant. You can write outside 1 plus I square, integral 0 to 1 x dx. So 1 plus I square can be written as 1 plus I square plus 2I into integral x dx is x square by 2. Limits are from 0 to 1. So I square is minus 1, so 1 minus 1 is 0, so this total part becomes 0, so you'll get 2I into, so if you substitute the limits you'll get 1 by 2. 2I into 1 by 2, so 2 gets cancelled, you'll get I. Okay, so this is the value of integral for this path y is equal to x. Next, see the second one. So y is equal to x square, you have y is equal to x square, z is equal to x plus iy. Iy is x square. Okay, so z is equal to x plus I into x square. Then what is dz? Dz becomes dx plus I into 2x dx. So it will be 1 plus 2ix into dx. This is dz. Okay, so now the given integral I is equal to integral 0 to 1 z. In the place of z you have to write x plus I into x square into 1 plus 2ix dx. Right, so if you multiply, what will happen? X into 1. X into 1 is x plus x into 2ix plus 2ix square plus ix square into 1, so it will be ix square plus ix square into 2ix, ix square into 2ix, this total dx. So integral 0 to 1 x plus, so 2ix square plus ix square is 3ix square plus what will be this? I into I is minus 1. Right, x into x is x cubed, so it will be, instead of this you'll get minus here, minus, so I into I is I square, so I square is minus 1, so I'm writing minus 1, 2 into x cube dx. So integral of x is x square by 2 plus 3I into integral of x square is x cube by 3 minus 2 into x to the power of 4 by 4. Limits are from 0 to 1. So if you substitute limits, so it will be 1 by 2 plus I, right? So 3 gets cancelled, so I into 1 is I only, minus 1 by 2. So minus 1 by 2 plus 1 by 2 gets cancelled, so you're getting value is I. Okay, so for y is equal to x, you are getting value of this integral is I, and for y is equal to x square also you are getting the value I. Okay, so why this is happening is, I'll take one more slide and I'll tell you. Okay, so we have got integral 0 to 1 plus I z dz is equal to, okay, I for path y is equal to x, similarly y for path y is equal to x square also. Okay, so what is the important point here you have to remember is, if the given function f of z is analytic, if the given function f of z is analytic, then the value of line integral, depends on endpoints only, but not on the path. Okay, so in the previous video I have taken one more example of x square minus iy dz is equal to, so I have got 5 plus I by 6 and 5 minus I by 6. So 5 plus I by 6 I have got for y is equal to x square, and for y is equal to x I have got this. So another important point is, if f of z is not analytic, then the value of line integral, depends on path, but not on endpoints. These two are very, very important points if you are preparing for any competitive exam. Okay, so here it is an analytic function. We know that z is an analytic function. This is not analytic function. So the function is not analytic. That is why for different paths you are getting different answers. That is what I have written here. If f of z is not analytic, then the value of line integral depends on path. So if path varies, then line integral value also varies, but not on the endpoints. But if you have the f of z is analytic like this, then value of line integral depends on endpoints only, but not on the path. That means, see, if you have z into dz, okay, z into 0, integral 0 to 1 plus I z into dz. So I will take this complex term, so integrate in terms of complex term only. So z dz integration is z square by 2. Limits are from 0 to 1 plus I. So I am substituting the upper limit, so it will be 1 plus I whole square, because in the place of z you have to substitute 1 plus I. So 1 plus I whole square divided by 2. So it will be 1 plus I square plus 2I divided by 2. So I square is minus 1. So 1 minus 1 becomes 0. So these two will be cancelled off. So you'll get 2I by 2, which is equal to I again. So the same value. Okay, so it depends only on the end points. So this is the starting point, 0 is the starting point, and end point is 1 plus I. So here the integral depends only on end points, but not on the path. So that is why, irrespective of path, for any path you are getting, for these two paths you are getting the same value for line integral. Okay, so you are getting the same value for the line integral, because f of z is analytic. Okay, so remember these two very important points. Okay, and next we'll see one more problem on this. So he has given, evaluate this function along curve C, z is equal to 4. So when you are given with a function like this, that is mod z is equal to 4, the curve like this, mod z is equal to 4, so you can solve it using polar form easily. Okay, so solving this using polar form is easy. Okay, so instead of solving using Cartesian, you can go for polar form, because z is equal to r into e power I theta. So z is a circle of radius 4, right? Mod z is equal to 4 means z is a circle of radius 4 centered at origin. So this radius is 4. This is minus 4, of course. Okay, so this is your mod z is equal to 4. That means if you take z is equal to r into I theta, so z is equal to 4 into e power I theta. So dz is equal to 4 into e power I theta. So I am converting this z in terms of theta. Okay, dz is equal to 4 into e power I theta. E power I theta differentiation is e power I theta only into I, because in differentiation is with respect to theta. 4 into e power I theta. So 4 into e power I theta differentiation is e power I theta only, but since it is multiplied by I, theta is multiplied by I, so I am writing I into d theta. And what are the limits for theta? Theta limits are from 0 to 2 pi. Why is 0 to 2 pi? It is covering entire 4 quadrants. So it starts from 0 and ends at 360 degrees. 4 quadrants are being covered in a circle. So theta limits are from 0 to 2 pi. Right. So I am writing 0 to 2 pi. 0 to 2 pi. Okay. So this can be written as 2 plus 4 by z. 2 plus 4 by z. Of course, you cannot substitute this. Wait. So I'll take the same value. C 2z plus 4 by z dz can be written as integral C 2 plus 4 by z dz. Now I am converting this z into theta. So theta is equal to 0 to 2 pi. This integral, same integral I am taking. Okay, this same integral I in terms of theta I am converting. 2 plus 4 by, what is z? Z is equal to 4 into e power I theta. 4 into e power I theta into dz. dz is 4 into e power I theta into I d theta. Okay, so this is equal to integral 0 to 2 pi. What will happen? So 2 plus this 4 and 4 gets cancelled, so this becomes e power minus I theta. This e power I theta, if you shift it to numerator, so it becomes e power minus I theta into, so this 4i is a constant, you can write outside the integral. Okay, so I'm writing it outside the integral, 4i into e power I theta d theta. So 4i into integral 0 to 2 pi. So when you multiply 2 with e power I theta, it becomes 2 into e power I theta plus 1. So e power minus I theta, e power I theta gets cancelled off, so you'll get 1 here, d theta. Okay, so 4i into 2. So 2 is outside, so 2 into integral, so I'll write directly 2 into, so 2 is a constant right and outside, so integral of e power I theta d theta. E power I theta d theta is e power I theta by I. Integral of e power I theta divided by I. Okay, so limits are from 0 to 2 pi. Limits are from 0 to 2 pi. Okay, plus next integral of 1 d theta is theta. Limits are from 0 to 2 pi again. So 4i into 2 by I into what is, you'll get e power I into 2 pi minus 1 plus 2 pi. Okay, so what is e power I into 2 pi? E power I 2 pi is cos 2 pi plus j sin 2 pi. So cos 2 pi is minus 1 whole power n. N is 2, so minus 1 whole square plus j sin 2 pi is 0. So plus j into 0. So this becomes 1. Okay, so this is 1. So 1 minus 1 is 0. So this total part is 0. So 0 multiplied by 2 by I is also 0. So this total part will become 0. So 4i into 0 plus 2 pi. 0 plus 2 pi. So we'll get 8 pi I. 8 pi I. So that is the value of this integral, given integral over this circle. Okay, this is the line integral of the given function over the circle. Okay, so there are many other simple ways to solve this problem, right? So Cauchy's integral formula is there, Cauchy's residue theorem is there. In order to solve this line integral easily only, we have those concepts, Cauchy's integral formula and Cauchy's integral theorem. Okay, so we'll discuss about that in my upcoming videos. Okay.